Okay, so let's start with the assignment. So in the question 1, it is given a function fx which is the best fit for the data given in table 1 recorded by a student is. Okay, best fit is given as fx is equals to minus of 1 minus x minus 1 whole square into x minus 3 into x minus 5 into x minus 7 plus c. So we have to find out the value of c so that the SSE, that is sum squared error, will be minimum. So let's first find out the error. So we are given fx as x minus 1 whole square x minus, so you can clearly see that let's find out x equals to 1. Okay, so x equals to 1 comes out to be 1 minus 1 whole square, 1 minus 3, 1 minus 5, 1 minus 7 plus c. So here you can clearly observe that because of this term, whole of this expression comes out to be 0. So basically we have f of 1 equals to c, and similarly we will have c equals to f of 3 equals to f of 5 equals to f of 7. Basically all of these will come out to be the same. Okay, so now we don't have to find f of 7, so this cancels out. Now we are left with f of 2 and f of 4. So let's find out f of 2. So this comes out to be minus of 2 minus 1 whole square minus into 2 minus 3, 2 minus 5 and 2 minus 7 plus c. This on calculating comes out to be 1 minus 1 minus 1 actually. Then this comes out to be minus 3 and this comes out to be minus 5 plus c. So there are totally 4 negatives. So this becomes positive and this is 15 plus c. Now let's find out f of 4. That comes out to be minus 4 minus 1 whole square, 4 minus 3, 4 minus 5, 4 minus 7 plus c. So this comes out to be 3 square, that is 9. So negative sign, this will be 9, this will be 1, this will be minus 1 and this will be minus 3 and plus c. So you can see there are three negative signs, so it would remain negative. Minus of 27 plus c would be the answer. Okay, so now we have to find the SSE. So basically we have to square the errors and then add them. So we know that for 3 of the terms, that is 1, 3 and 5, we have c as the error. So SSE is going to be, basically it would be 3c square, and since we are calculating the error, so it would be minus 4 and minus 4, that is it would be 3c square minus 12. Okay, then the next comes out to be f of 2. So f of 2 we found out as 15 plus c, so it would be plus 15 plus c minus, and the value is given as 19. Okay, then it would be c minus 27 minus, it would be plus because it is given as minus 23. So this will come out to be 23. And basically what we have to do is we have to add all these errors. So this is going to be 3c and we have to add the square of all these errors. So this comes out to be 3c minus 12. We can write this as 9. We can take 3 as common and this comes out to be c minus 4 whole square plus this can be written as c minus 4 whole square plus this can be easily written as c minus 4 whole square. Okay, so now this comes out to be 9. Okay, this becomes 11 times c minus 4 whole square. So now we have to find the minimum SSE. So you can clearly see that SSE will be 0 if c is equals to 4, and that would be the minimum value of SSE. So we can simply say that c should be equals to 4. The second question, it is given that a function goes from R to R and a function G goes from R to R. Both the function have domain R and codomain also as R. So fx is defined as x cube minus 6x square plus 9x minus 4, and gx is defined as minus of 2fx. Okay, so let's see the option. So you can see options are mostly about the turning points. So let us find out about the function and let us try to plot it roughly. Okay, so we are given that fx is equals to x cube minus 6x square plus 9x minus 4. So if you see, you can clearly notice that 1 is a root of this equation, that is 1 minus 6 plus 9 minus 4 is equals to 0. So yeah, 1 is a root. So fx has a factor x minus 1. Okay, so basically at 1 it will be touching x-axis. Okay, now if we put x equals to 0, we will know where it will cut at y-axis. So putting x equals to 0, we get 0 minus 0 plus 0 minus 4. So basically it comes out to be minus 4. That means it would be in the negative. Okay, so somewhere here. Now since we can see it is a cubic, it will have two turning points, and we have found one turning point as 1. So this would be one turning point and it is starting like this. So it will turn once here, and so the graph will look something like this. Not exactly, but something like this. Okay, and as you know, let me change the color. So gx is given as minus 2fx. So let's leave 2 right now and just consider minus. So when we apply minus outside the function, actually it becomes the mirror image along the x-axis. So the function minus fx would be this one. Okay, and don't mind, this is not precise, but they are cutting at the same point. Okay, and since it is multiplied by 2, basically the magnitude will increase by 2. So the graph would look something like this. Okay, it is still cutting at the same point, but the magnitude is increased. That is, if this comes out to be a minus a, this would be 2a. Okay, so we have plotted both the graphs. So now we can answer the questions. So let's see what's given in the options. The first option is G has two turning points and there are no turning points with positive y coordinate. So G, this red one is G graph, has two turning points. That's right, we have two turning points in G, and it is saying it doesn't have a turning point in positive y axis, but we have a turning point in positive y axis. So the first point, this is wrong. Second option is G has two turning points and there are no turning points with negative y coordinate. So you can see there are two turning points and there is no turning point in the negative y coordinate. So this comes out to be a correct option. F has two turning points and x coordinates of both the turning points are negative. So fx is the blue graph and fx has two turning points and x coordinate are negative. So this is false. X coordinates are not negative, so this is not correct. F is strictly increasing in 4 to 10. Okay, so the blue graph is fx and they are saying it is strictly increasing in 4 to 10. So basically 4, if 4 comes after this point, then it would be increasing. But if you observe, they are giving it directly. So if you observe, 4 satisfies this equation. If I write 4 cube minus 6 into 4 square plus 9 into 4 minus 4, and I solve this, I get 64 minus 96 plus 36 minus 4, and this comes out to be 0. So basically 4 is also a root and x minus 4 is also a factor of fx, right? This means the point where it is cutting x-axis is basically 4, 0. So after 4 it is strictly increasing, so this option comes out to be correct. So we have answer as B and D. You might also have a doubt that why x equals to 1 was a turning point as well as a root. So if you differentiate fx, that is, if you find f dash x, it will come out to be 3x square minus 12x plus 9, and you will find out that 1 satisfies this equation also. This comes out to be 0. So basically 1 satisfies fx as well as f dash x, so it is also a turning point. Let's move to the next question. Okay, so in the third question it is given an ant named B wants to climb an uneven cliff and reach its anthill, that is its home. On its way home, B makes sure that it collects some food. So a group of ants have reached the food locations, which are the x-intercepts of the function fx given as x minus 5, x minus 1 whole square minus 1. As ants secrete pheromones, that is a special form of signal by which they can detect and reach the food locations. B gets to know the food locations. How many such locations are there? So basically this is a question in which we have to find the x-intercept, and x-intercept is basically y equals to 0. So we have to find fx equals to 0. So let's just solve it first. So this can be simplified as x minus 5 into x square minus 2x plus 1 minus 1, which comes out to be x minus 5 into x square minus 2x. Now we can take out x as common, and this comes out to be x into x minus 5 into x minus 2. So we can clearly see that fx equals to 0 has solution as x equals to 0, plus 5 and plus 2. So basically there are 3 such food locations that we can figure out. So our answer is going to be 3. In the fourth question, it is given which among the following function first increases and then decreases in all the intervals, that is minus 6 to minus 4, minus 3 comma 1 and 1 comma 2. So basically we have to find out that the functions given in the options increase and decrease, how they increase and decrease. So we have to find out their nature. So we are going to do with this with the number line. We are just going to see when they are positive and when they are negative, and that way we will know when they are changing their direction. Okay, so let's start with option 1. So option 1 has plus 1, plus 2, minus 3, minus 4, minus 6, minus 7 and minus 8 as its roots. So let's first remove minus 5 is not there. So firstly we can clearly see that on putting x equals to 3, definitely we are going to get a positive outcome from the first option. So it is positive when the value of x is more than 2. Then at 2 we have odd power, that is power is 1, so sign will change, so it would be negative. Then at 1 we have even power, sign won't change, so it will remain negative. Then next we have minus 3, so minus 3 has an odd power, so sign will again change, so this will be positive and this whole area will be negative. Then at minus 4 it has odd power, so again the sign will change, it has power as 1. Then we have minus 6 which has even power, so the sign won't change, it will remain negative. Then we have minus 7 which has an odd power, that is 1, and 8 also has an odd power, that is 1. So you can clearly see when the graph is positive and when the graph is negative. So we know that graph is turning if it is going from positive to negative or negative to positive. Now we have to check in interval minus 6 to minus 4. So between minus 6 to minus 4 the graph is negative, so the graph must be like this, that it is negative and it is going to be positive. So it is first decreasing then increasing, so this one won't be the answer from the first check only. So let's remove this, and now let's consider option 2. So it has Let's remove this first. So it has my 1 as a root, 2 as a root, minus 3, minus 4, minus 6, and minus 9. Okay, so we can write this as 9. Now let's check out. So when the number is greater than 2, it is definitely positive. We can clearly see if you put 3 here, it will come out to be positive. Then at 2, the power is odd, so the sign will change. 1, the power is even, sign won't change, so this whole part would be negative. At minus 3, it is again odd power, so sign will change. At minus 4, it is odd power, so sign will change, this will be negative. At 6, it is odd power, sign will again change. And at 9, it is again odd power, so sign will again change. Okay, so this is how we are going to represent the graph. Now let's check out between minus 6 to minus 4. So minus 6 to minus 4, it was positive there, then it went negative, and then it again went positive, so it again decreased and then increased. So again it is not satisfying the condition of first increase and then decrease, so this is also not the right answer. Let's move to the third option. So let me clear this out. Now the third option has 1 as the root, 2 as a root, then minus 3, minus 4, then it has plus 5 actually. So it would be 5, and then it has minus 6. So let us solve in here. So we can clearly see that when the number is greater than 5, that is if it is 6 or 7, this will definitely come out to be positive. So this is going to be positive. Then 5 has odd power, so this is going to be negative. It will change sign. Then 2 also has odd power, so it will again change sign. 1 has even power, so it won't change sign, it will remain same. Then again minus 3 has an odd power, so it will change. 4 also has an odd power, minus 4, so the sign will again change. And minus 6 has an even power, so sign won't change. Okay, so again let's check out in minus 6 to minus 4. So we can clearly see at minus 6 it is going to touch x-axis, then it is positive, and then it is again going to touch y, and then it is going to be negative. So you can clearly see in minus 6 to minus 4 it is first increasing and then decreasing, so this satisfies. Then in minus 3 to minus 1, so at minus 3 the graph would be like this, then it will be positive, and then it will again reach 1. So it is increasing and then decreasing. So in second area also it is first increasing and then decreasing. Then in 1 to 2, this condition again satisfies, it is again increasing and then decreasing. So our third option is correct. Okay, now let's move to the fourth one. So let me clear this out. So in the fourth option we have 1 as a root, then we have 2 as a root, then we have here 0, 1, 2, then we have minus 3 as a root, then we have minus 4 as a root, then we have plus 5 as a root, then we have minus 6 as a root, and we have minus 11 also as a root. Okay, so let's consider this minus 11. So now let's try to find out the positive and negative region. So we can clearly see that after plus 5 this is going to be always positive. Then 5 has an odd power, so the sign will change. Then 2 also has an odd power, so sign will again change. 1 has even power, so sign won't change. Then 3 has odd power, so sign will change. 4 also has odd power, so sign will again change. 6 has an even power, so sign won't change. And 11 has an odd power, so sign will change. So that's how the graph will look. It will be something like this. It will look something like this. Okay, so we have to check out in minus 6 to minus 4. So this satisfies, it is first increasing and then decreasing. Then in minus 3 comma 1 also it is first increasing then decreasing, and then 1 comma 2 also it is first increasing and then decreasing. So option D also satisfies. So we are done with question number 4. The answer is C and D.